Greetings, this is Sean, of course, and today I'm going to be doing some more of the electronics lessons. I've got another thing, some other things I'm going to show you today. As you'll see in the video, several people have been asking about how to wire up the LEDs for the dollhouse and how to use switches properly. So that's what I'm going to be doing today. It'll all be on the computer. There won't be anything demonstrated, physically. Everything will be on some applications on my computer, so you'll get to see it there. So anyway, stay tuned, and if you have any questions, leave them in the comments below, and I'll be glad to answer them the best I can. And also, please let me know if you'd be interested in doing a live Q&A type of thing on a weekend or something like that. I'll be glad to do one of those if that's something that I get enough interest in. So anyway, sit back, relax, enjoy, and hope you learn a lot. And have a better day, as I always say. I'm going to be talking about electronic switches and how to do lighting, different ways of setting up your lights and stuff. I know we talked about a basic circuit of how to make a light turn on, and some basic soldering, which I will put a link to that video in the description below and up above. But today I've had several people email me, and one person commented about how to do the switches, what kind of switch they need to do the different kind of lighting and whatnot. So I'm going to try and answer that question today. I'm going to get rid of this note real quick. These are three different kinds of switches. Actually, these two are very similarly related here, this S1 and S2. And S3 is different from the others. Now, this one here, if you notice here, it says pin 3 is always connected with pin 4. And this is pin 4 here, and it says it's always connected to pin 3. This is what's known as a momentary switch here. When you push the button there, it turns on. When you lift your finger off the button, it turns off. So, and then here, pin 1 and pin 2 are always connected. So this is just a very basic switch, just like this is a very basic switch. This is called a reed switch, and it activates when you use a magnet. A magnet will pull these two together and cause the connection to be complete or closed. When the circuit is closed, that means that there's a connection between this pin and this pin. If it were open, like it is, there's an open space in between, no electricity can flow through, and therefore it doesn't turn on. This switch is a single pole, double throw switch. This one here and this one here is a single pole, single throw switch, meaning there's only one pole in between, and it only activates one set of contacts. This is the same. There's only one set of contacts between these two pins and these two pins, and there's a single pole like this that goes between them. I'll show you a different drawing too here in just a second. This is a single pole double throw, which means that there's a single wire or connection between this pin and this pin, or between this pin and this pin. And let me switch to this drawing here, and you'll get a better idea. This is switch 1, the momentary button switch, and when you push the button, this wire goes down and it connects to this set over here, and it completes the circuit. It closes the circuit so that electricity can flow from here through this wire to this one and out. Same with this one. When you put a magnet next to it, it draws this arm down so that electricity can flow from here through that wire and out the other side. With this one here, when you flip the switch one way, the electricity goes from here over to this pin. When you flip it the other way, it goes from here over this way to this pin. So that's where the single pole double throw comes into place. Now there are some that are called a double pole double throw, which means that there's two of these And let me see if I can pull one of those up real quick. Show parts bin. Oh, where's my parts bin? Parts. Find a double pull, double throw. By the way, this application I'm using is called Fritzing, Fritzing, and it's an open source program used for electronics and Arduino use, and I'll get into it a little bit later. I'm just using this to show you the thing. This is the one I'm looking for. Now you can see here, let me move over a little bit. This is a double pole, meaning that there's two poles here and there's double set of poles. So you could have one circuit connected here that would go up to here and across to there. At the same time, you would have another circuit here that would come here through this to here, and then when you flip the switch, it goes from here down to here, or from here down to here. So, but you'd have to be able to control both of these at the same time with one switch. That's where double pull, double throw comes into play. That's DPDT. This is SPST, or single pull, single throw. And this is single pull, double throw. Now, with all of that in mind, let's switch over to here. I made up some circuits, and this is a single pull, single throw. I'm going to show you this one here. Clicked on the wrong button. This is called Tinkercad by Autodesk, and this is a way of creating circuits, and you can also create 3D designs and whatnot, but I don't use this for that. I find it to be too complex to do that. So let's go to this single pull, single throw demo. Okay, now what we have here is a battery, that same momentary switch where these two pins are connected and these two pins are connected, but they only connect through this switch here. Then I've got 3 LEDs and a resistor. Now what this application does is it'll actually run it to where you can actually see it working, and it'll tell you if you have any errors or whatnot in your circuit. Now what I've done was, like I said, I put a single pull, single throw here so that when I push this button, it'll light the LEDs up and complete the circuit. But somebody had asked, and I don't remember who it was, and I apologize for that they were concerned about how many LEDs you can have before it wouldn't work, before it would either overload or not have enough power to make it work. Well, that's what the beauty of this application does. If I click on the Start Simulation button and I press this button, you'll see that the LEDs don't turn on. I'm actually clicking this button. But what I can do is, if I take this wire, actually I have to stop the simulation first. If I take this wire here and move it to here, bypassing this LED, so it's bypassing this one here, and now I start the simulation, I can press it and you can see that they barely turn on. There's barely enough power to turn on those 2 LEDs. Now if I stop this simulation again, and I'm going to move this wire over to here, bypassing these two, so these ones aren't in the circuit anymore. We'll start the simulation, and if I click it, it's even brighter. So that means that with this circuit, you can barely get 2 to work, but you can definitely get 1. And you can change the resistance in this resistor. That just limits the current that goes through it. Because if you didn't have that in there, and I'll show you that here in a minute. Actually, I can show that to you right now. Let me delete this resistor, and if I click on here and drag that, we'll make that a black wire because that's the negative. And let me start the simulation now. When I click it, you'll see that there's a little exclamation point, and it says current through the LED is 61 milliamps, and it's recommended only 20 milliamps, which means there's too much current going through that LED and it would probably explode. It would probably burn out. So let me stop the simulation, I'll take this and we'll bring it back over here. Start it up again, and I can click on it, and you can see that they barely light up. Just like that, but just like before, without the resistor. So that's what the resistor does in an LED circuit, is it limits the amount of current going through the circuit so that you don't burn out the LEDs. Now, I'm going to stop this, and I'm going to go to my other circuit here that I made, this one. And again, this is a single pole, single throw, just like before. Let me create a new circuit. Oh, no, I didn't want to create a new circuit. Darn it. I need to click on here and go tinker this. Now, this is a single pole double throw like I showed you before, but I'm only using one side of it. So in all intents and purposes, this is a single pole single throw because it's either on or off for this circuit. Now what I've done is I've put this into parallel circuit, which means that the circuit goes to here and to here and to here all at the same time, instead of through one and another, which is called series. So they're parallel to each other, just like you can see. I could take this one off and it would still, the other two would still work. Think of Christmas lights. When one goes out, they all go out. Well, this one doesn't. So I'm going to start the simulation like I did up here. And you can see that all three of them are on. And if I turn this off, they all turn off at the same time. Just like that. That's a single pole, single throw, and these are in parallel, so now they're all three are nice and bright compared to the other one that was in series that was dim and I couldn't even get three to light up. So this is how you want to wire multiple lights in a circuit, is you want to have them parallel with each other. In other words, this point here and this point here and this point here are all, you know, separate from each other but connected to one switch. Anyway, if I were to move, let me stop the simulation. If I were to move this around, well, I can't do that. Let me take this one and delete it just for the moment. And we'll start the simulation up again, and you can see they're still lit up. In other words, they're all connected to one point. I could even remove these resistors and they would still work. But anyway, you always want to have the resistor with the LED. So you can see that these two are still working even though that one's missing. So let me stop that. Undo that. Now, let me go to the single pole double throw. Let me go to this other one and I'll show you how a single pole double throw circuit works. Tinker this. Now, here I've got the same setup as before. I've got three LEDs in parallel on one side and three more on the other side. And I've got a single pole double throw on this side. Now, the battery is connected to the common pin. If I go to here, I'm connecting it to this pin here is where the battery goes to here. And then this one is this side over here. And this one is this side over here, and they all come back to the negative side of the battery. Now when I start the simulation on here, you can see that this side here is lit up, and when I toggle the switch, this side lights up and this side turns off. That's what the single pole double throw does. So you can have two circuits on one battery, but one side will always be on, the other side will always be off, and then when you toggle the switch, they switch sides. So anyway, I hope that this helps as far as knowing how to wire up your switches and what kind of switches you want to use for different applications. So let me stop this. Let me go back to this other one. Let's go back to here. Now, you would use a single pole, single throw in an instance when you want the lights either on or off. There's nothing else, and you can have multiple LEDs or lights, whatever. Think of the lights in your house. You turn on one switch and one light comes on. Turn the switch off like a desk lamp. That's what this basically is. And let me go to the other one. Let's go to this one. In this one, think of this as being like a long hallway. You've got light at the door, a light in the middle of the hallway, and light at the end of the hallway. So when you want all the lights in the hallway to come on, you turn it like that. If you want them all off, you turn them all off. Now I could take this switch here. Let me stop this. Take this push button switch, delete this. We'll move this in its place. And I can take this and put it to here. And then take this and put it to there. And we'll start the simulation. Now you can see that they're all off. And when you hit the button, they all turn on. When you release the button, they all turn off. Just like a switch in your hallway, in your house. Just like that. So those are examples of how to do lighting, how to do switches, the way you should properly, if you want to do more than one light, this is the way you want to set it up. You want to have one light, you want them in parallel like this. So I'm going to rebuild this one to show you how this is done. Oh, I gotta stop simulation. Let me delete all of these. We'll leave the switch. Let me get rid of this. So, I want to take an LED, and I'm not going to worry about the resistor, just for the sake of easiness. I'm having a hard time talking today. And I'm going to take this, I'm going to put it over on this side, just for the sake of easiness. And bend that down like that. Now, I'm going to take this LED here, I'm going to attach it to there like that, and then this one's going to come around over to here. Don't worry about the warning sign that I'm going to get having that on. See, the little warning, it just tells me that there's too much current. I'm not worried about that at this point. I'm just showing you for demonstration purposes. So let's stop. And then if I want to add a second light, this is at your foyer entrance to your hallway. This one's in the middle of your hallway. I would take, remember, anode is positive, and attach that there. And then this one I'm going to attach to the battery over here. Bring it around just so you can see that they're all separate. And then I'm going to add a third one. We'll put it here. This is at the end of your hallway. I'm going to attach that wire to there. And then I'm going to attach, oops, not there. Attach from there to there. And now when I start the simulation, you can see that they're all lining up. Now, the practical way to wire this, and let me get rid of these wires, is instead of bringing them all to the switch, you would take this anode and attach it to this anode, this cathode to this cathode. So you're not running so much wire. Same with down here, and same with here. Oops. From here to there. And now when I start the simulation, you'll see that they all three light up the same way as before, because they're all connected. So you could take this battery, or this LED here, and delete it, and this would still be connected here. Or let me say that a different way. If this LED were to burn out and not work, this connection here would still be connected, and this light would still work. Whereas if you had them in series with each other, in other words, it went from here, then through here to this one, and then from there to this one, and then to the battery, if one light went out, they would all go out, just like the old Christmas lights, and then it wouldn't work properly. So anyway, this is the proper way to light up multiple lights on a single switch and a single battery. Now what I could do is I can take this here, I'm going to delete that wire, I'll put a resistor in here. Let me rotate it like that. And we'll take a wire from here to this battery to there, and there to there. And now when I start it, you can see I'm not getting that warning, but it's very, very dim. So I could change this is a 1 kilo ohm resistor, 1K ohm. So I could change it to, say, a 220 ohm resistor, like that. Now when I hit the light, see, they're brighter. And they all three turn on, just like that. So anyway, I hope that this has helped. I hope this makes sense. And if you have any questions or comments, please be sure to leave them in the comments below. And I will put some links to this Tinkercad and to the Fritzing app in the description below. And like I say, if you have any questions, let me know, and I'll be glad to answer them. Take care, and as always, have a better day, as I always say.